Hi everyone, welcome to my YouTube channel Tech Data Engineer. So in this video we will discuss the basic concept regarding Spark, like what is job, stage, what is tag, what is lineage graph, why we are creating, what is called shuffling. Because most of the time some basic questions, some critical questions they used to ask from these topics. Okay, so you should be very clear about what is so when our stage is getting created, when DAG is getting created, uh, if shuffle will happen, in which case a stage will get created. Stage is getting created on transformations or actions for each particular transformations, how many stage is getting created. So you should know the concept. So some interviewer used to ask questions related to that only. Okay, so I'll explain the basic concept from job and then again DAG, lineage concepts and everything. Okay, in this video. So first we'll start with the job in PySpark. Okay. So what is if someone will ask what is job in PySpark? So job is nothing but so if someone will ask regarding the job, so job is nothing but it's like a action. So action is like collect, count, then save as a text file or show. So job is nothing but job is triggered by an action in your PySpark code. Okay. So wherever so if you have a PySpark code and if there is a action getting triggered in your job, action getting triggered in your Spark code, then that is called the job. So let us understand with a simple example. Suppose I have taken RDD, then I have created a Spark concept text file, file.txt, and then I have filtered the RDD lambda line error in line and then count equals to filter dot count. So if I am doing the dot count is a action operations. Okay, so this will trigger a job. So job is nothing but whenever there is a actions that is trigger a job. Okay, so job you or you can consider like in any PySpark code job is triggered by an action. Okay, so in this code particular, job only start when we'll call filter dot count. Okay. So job correspond to one complete competitions triggered by an actions. Okay. So then we have to understand key point about job like job created only by an actions, not transformation. So suppose there is a map then other functions flat map and all. So if this will apply to a certain PySpark code, it will not create any job. Okay, so job only get created, it will associated only with the actions, not with the transformations. Okay, so Sparks breaks the job into different stages, and then each stage have a different task. So hierarchy is like, so top layer is the job, then job is getting created with a different stage based on the transformations, and then the task is based on the partitions. So if suppose there is a there is a one PySpark file like example.py PySpark file. So if there is a actions, then what will happen? It will create a job. Okay, it will trigger a job. Then associated with that particular actions, if there are multiple, you can say transformation, then it will create a different stages. So a stage is also getting created based on the wide transformations. If there is a narrow transformations, the stage is within the partition, so it will not create the different stages. Then for each stage based on the partitions, we will create the number of tasks. Okay, so we will see the hierarchy later. Okay, but for now we can understand like any job in your PySpark PySpark code is associated with the actions. Okay, now we will understand the what is stage. So a stage is nothing but a stage is a set of operation that can be executed without suffering data between the partitions. That is also called pipeline. Okay, it is something like you can say subjob where a Spark can keep processing locally on the same code. So Stage basically divided into two types. Okay, shuffle map stage, like that produce that data to be shuffled from downstream operation like group by key, reduce by or join, where there is a shuffle required. So if shuffle required, like like transformations like group by key, reduce by key or join. Or second is called resultant stage that produce the final result like writing to the disk or returning value to the driver node or saving the output. So that there are the two types of stages. Okay. So what key point we need to understand in case of job stage is Spark create a stage for each wide transformations, one that required the data shuffling. So Spark only create, first we have to understand Spark create the stage for each wide transformations. Okay, so if there is a wide transformation in your job, it will create a stages. Okay, newer stages. So once that, so what is called while transformation, when there is a shuffling required from one partitions to different partitions, that is called wide transformations. And within the partitions, if there is a shuffling required like one to one mapping, you can consider, that is called narrow transformation. So narrow transformation is something like map filter. So narrow transformation stay within the same stage. Okay, so you don't need to create the different stage for that if there is a narrow transformations. If there is a wide transformation, you need to create a different stage. Okay, so are we clear with that? So we understand the stage got created for each wide transformations, job getting created for each actions. Okay, now understand with a simple example. So I have taken again the same example RDD sc.text file, file.txt. So we have taken a map function, rdd.map lambda x. So every number associated with one, it is one-to-one mapping. So this is basically a narrow transformation. So we will stay with the same stage. So whatever stage we are running or processing with the stage, we will not create a different stage because this is the narrow transformation. Okay, and then again it will come as a reduced equals to mapped dot reduce by key lambda x comma y equals to, we will sum up that things. Okay, so reduce by key is basically a wide transformation. So wherever there is a wide transformations, where there is a shuffling required, it will create a different stages. Okay, then again count equals to reduce dot count. So action, so there is a actions, so we will trigger a job. So we need to understand, if there is a actions, we will trigger a job. There is a wide transformation, we will create a different stage. If there is a narrow transformation, we will stay with the same stage. Okay, so stage one is the text file map, no shuffle required. So this will create a stage. Then again reduce by key shuffle operations. So it will create a different stage here in this code. And there is a count. So count will create a result stage. Like this is the final thing where we are counting and storing to the count variable. So this basically actions will create a result stage. So these three stages will create based on this job. So if we'll understand this code, three-line code, it will create a four-line code. It will create a three stages. Okay. So this is basically called a stage. Now coming to the topic called task. So first we understand what is job. Then each job has the different stages. Then stage have the different task. So task is nothing but it is the smallest unit of work sent to an executor. Okay. So for executing each things, we send each task to a, like it is the smallest unit of work that is called task to each executor. So each stage is split into tasks, one per partitions of the data. So if you have RDD have five partitions, suppose if you have RDD have five partitions, so Spark will launch five tasks for that stage. Okay, so each task is a piece of code like a function running on a single partitions. So you can consider if there is a five partitions in a single RDD, then it will create a five tasks for each stage, for that stage, not each stage, you can consider for that stage. Okay, now key point we have to, what key point we have to remember, tasks are executed in parallel by the executor. If task fail, Spark retries it, default might be four times. Okay, so task do the actual computations like reading data, applying function, or writing to the result. So we understand first is the jobs. If there is a actions job getting created, Under that, there is a stage. If you'll come hierarchy down the hierarchy, we'll get the job. So job has two jobs. There is a resultant job, and there is a if there is a shuffle partitions happen, it will create a different stage. If no shuffle partitions, it will stay with the same stage. Then based on the partitions for your RDD, if there is a five partitions for each stage, it will create a five task, and this task will get executed to the each executor. Okay. Now come to the Spark UI view, how we will understand through the Spark UI view. So whenever you run your code to the local, like local host, so job, all job triggered by actions, stage, all stage busy within each job, and task inside each stage. So hierarchy is like job, then each job has stage, each stage has the, you can say, task. So, okay. So why we are using Spark UI? Spark UI you are using for debugging and performance tuning. We will see where which stage it is taking much time so that we can optimize the code. So we are using Spark UI view if we are getting any latency while running your Spark job. Okay. So we will understand through a more real world example from I have taken an example like Spark SQL, import a Spark session, then job stage task. So there is a we are reading the data. So reading is data is basically Spark read text is a transformations. Then we are filtering the data. So filtering data is a narrow transformation again. Then grouping the data is a wide transformation. Then df dot show. So it's basically a triggered. So it is basically a actions on the job. So job is basically triggered by dot show operations stage. So what is the stage? One stage is the df dot group by. So reading the data, one is the reading the spark dot read txt, reading and filtering the data is one stage, and grouping and counting is the other stage, that is the shuffling. So based on the number of partitions, if there are eight partitions, suppose if there are eight partitions, so each stage got eight tasks. Okay, so how many partitions are there? For parallel executor on the cluster, or you can consider an executor, we will get the each stage has the different task. So whatever the partitions we have, we will get a number of tasks. Okay, simple. Now, coming to the different topic, we will understand what is the driver, what is executor, how they are correlated, what is resource manager and all. Okay. So I'll explain with some real-time examples also. So what is basically a Spark driver? Okay. If someone will ask what is Spark driver, so how will explain that? So driver is the basically a brain of Spark applications. Okay, so what is first we will understand what is responsibility. So responsibility of a Spark driver is to run the main functions, okay, of the Spark application. Okay, whatever the your PySpark script is there, suppose it will run the main function. Okay, maintain the Spark context, a Spark session. So Spark session is created by the driver itself. Coordinate the job, entire job. So it will create the job, plan job, stage, and schedule task. So whenever uh, you have to create a DAG or you have to plan a job or a stage, it will created basically by a Spark driver only. Okay. Then for allocating the resource, for allocating the executor, for creating the executor, it will basically communicate with the cluster manager to request the resources. Okay. Send and then for each task, whatever the task we have, it will send the executor to monitor their progress. Okay. So think as a so suppose in your project there is a project manager, what it will do, it will take the resource based on the project requirement. It will based on the tech stack, it will hire the persons from, it will choose the persons from the different tech stack, and it will decide the task. Okay, it will define the task also to each person. So Spark driver is something like whatever your role of a project manager in your project. Okay. So it does planning, task delegations, and status monitoring. So everything is done by the Spark driver. Okay. So Spark driver, where it run? It run if you are running on your machine, like we are submitting the job a single machine, you can consider. Then it is called basically a local mode. In cluster mode, it will run on one of the node. Okay. So they also ask something. What is local mode, cluster mode? So cluster mode is something. It will driver program will run in one of the cluster, and in local mode it will run off the one of the your local machine. Okay, or you can say your machine. Okay, not remotely. Then what is Spark Executor? So a Spark Executor are the workers. Okay. So these are the actual processors. So the person who actually do the job, like each engineer or developer. So developer are something like a executor. Okay. So these are the actual processors that run your code and do the heavy lifting. So whatever the required things to do the execution of your task, it will done by the executor. So what are the responsibility for a executor? Run the task assigned by the driver. So what it will do, it will take the job and it will assign the task to the each executor. Okay, so run the task assigned by the driver is a task it has to do by the executor. Then store data in the memory or disk during the computations, like caching, persisting, everything be done by the executor. Report task status, a result back to the driver. If there is a failure, you have to executor have to report to the driver, or whatever the result back the resultant it has to give back to the driver itself. Then each executor run multiple tasks in parallel based on the core allocations. Okay. So whatever the suppose we have five executor, five job is it should run parallelly. Yes, okay. So life cycle launched at the beginning of the job by the resource manager, stay alive for entire life cycle of this application unless they are fail or preempted. So either if executor is getting failed or it is got preempted. Preempted means job getting created and it's got preempted. So in both the scenario, this is the life cycle of the Spark executor. So executor is nothing but they are like actual computations or data handling persons, okay, or actual developer you can consider. Now coming to the third part, that is resource manager. So resource manager is something like your hiring persons, like your HR or staffing team or resource team in your you can say project. Okay. So resource manager is a part of cluster manager in your system. So in case of Spark, we have the Yarn, Kubernetes, and Mesos. So Yarn have the you can say containers, Kubernetes have the pods to running the things. Okay. So what is the responsibility of resource manager? Allocate the containers. In case of Yarn, it will allocate the containers, and in case of Gate like Kubernetes, it will run the pod. Okay, for executor and the driver, track the cluster resources and handle the job scheduling across multiple Spark applications. Okay, a start and a stop executor on the different machine based on the driver request. So whenever driver request for starting of the executor, it will start the and stop the executor. Okay, so think it is like a HR team. It hire the resources, allocate the space, and ensure proper environment schedule. So everything is done by the resource manager. So till now, what we understand, what is job, what is stage, what is task, then what is called driver program, where it is run, where it is running basically, what is called client mode, cluster mode, what is called executor, what is the life cycle of executor, what is the resource manager. Okay. Now coming to the one more important topic, that is how they work together. Okay, so entire thing how they work together. So Spark driver start the application and connect to the resource manager. So what we have to do, if someone will ask what is the life cycle of your Spark code, so Spark driver start the application and connect to the resource manager. Then what a driver request resource to the executor. Okay, then manager what it will do, allocate the resource to across each cluster. Okay, then executor what it will do, executor start up, register with the driver and wait for the task. Then driver build the DAG, split it into a stage and task. Then the task is sent to executor for executions. Okay, then executor what it will do, it will run the task, store the data and result, whatever the result it has to the executor, it will return back to the driver node. Then when job is done, what it will do, driver and executor shut down. So this is your life cycle of your Spark application from starting whenever you are submitting your PySpark code or Spark submit command, how driver will allocate, how it will communicate to the resource manager, how executor is getting created, how stage is getting created, how task is getting assigned to the each executor, how executor compute the things and store back to the and give the resultant back to the driver, and how driver is getting shut down or executor is getting shut down. So if this is the life cycle of your Spark code. Okay. Now we will discuss two more topic, what is called DAG and what is called lineage graph. Okay. So in basically PySpark, DAG, direct acyclic graph and lineage graph, the crucial concept for understanding how a Spark executes job efficiently and fault tolerant. Okay. So why it is important in case of fault tolerant, and what is the job, how our job is getting tracked. Okay. So we will understand each like both the things one by one. Okay. So first we will understand the what is DAG. So DAG is nothing basically a direct acyclic graph. It is basically acyclic, like there is no loop. So DAG is basically a logical execution plan representing a sequence of computation in your PySpark program. So whenever in your Spark script, if you perform any transformations like map, filter, group by, so what it will happen? Spark does not execute them immediately. Okay. So whenever, so in your applications there are multiple transformation you can consider like map, filter, group by, and there are multiple actions. Okay. So so whenever there is a transformation happen, so Spark does not execute them immediately. Okay. Instead of that, it build a DAG of this transformation to track what needs to be done. Okay. So we'll understand certain more points. What is called direct? So direct means there is the edge of the graph have directions like one one operation to the next operations, one node to different one node to next node. You can consider a cyclic means no cycle exists. Okay, you can't loop back to the previous stage. So it represents the logical execution plan, not the physical execution, which is handled by the Spark scheduler. So this is not the physical, it is the logical execution. So the DAG is optimized before executions, like combining the transformations. So why DAG? Why we are using DAG? So a Spark uses DAG to optimize the job execution, like pipelining the narrow dependency. If there is narrow or wide transformations, we need to track all these things to optimize the job. Track the dependency between the RDD and data frame. If there is a dependency between RDD or data frame, we will track this dependency. If there is a fault tolerance happen, suppose there is a one failure happen, one executor failure happen, or node failure happen, how we will recover the loss of data during this failure? We will maintain this by the DAG. That's why DAG is important. We will understand through the one example. We have taken up a Spark SQL, Spark session. We have taken a DAG example. So first what we will do, we will load the data. Okay, spark.read data. We have taken the data.txt. We will do the transformations, one filter transformation, one with the map transformation, and we will perform the action. So what will happen if we'll try, if we'll like debug this code, what will happen? The transformation filter map are not executed. So if you can consider there is a filter and there is a map, this will not executed immediately. A Spark builder DAG with these steps. Okay, so these, if there is a transformation, it will create a DAG stage. If there is a this transformation map, it will create a stage. So Spark builder stage of this DAG of these steps. Okay, so only when last step you can see df3 dot count will happen. If this action will getting called, Spark trigger the job and submit to the DAG scheduler. So it will get submitted to the DAG scheduler, and based on that it will track the whatever the stage transformation it has, it will track back, and then it will compute and store to the result. Okay, so that's why DAG is important, and DAG is getting created. Okay. Now coming to the topic, lineage graph. Okay, so what is lineage graph? So lineage graph is essentially to the history of transformation applied to build a particular RDD or data frame. So how many transformations are getting like applied on that particular RDD? For tracking that, we will create a lineage graph basically. It tells Spark how to recreate an RDD if partitions is lost. You can consider as a fault tolerance. without recomputing everything from the scratch. Like we don't have to create everything from the scratch. So suppose let us consider example text file. We have taken the text file, we have taken the flat map transformation, then filter transformation, map transformation. So how the lineage will get created? So first there is already there is a flat map, there is a filter, there is a map. So this will create a lineage graph basically. So lineage information is stored by the Spark, and if any node fails, suppose this node getting failed or this node getting failed, it can recompute only the affected partitions using the lineage graph. So if suppose any node getting failed, so only that particular node is getting recomputed, and based on the lineage graph, we will store the result. Okay. Now we will understand the difference between DAG and lineage graph. Okay. So what is the purpose of DAG? What is the purpose of lineage graph? So DAG purpose is it is basically a logical execution plan for a complete job. Okay. This is basically for a complete job. uh, what is the lineage graph purpose? Okay, so lineage graph purpose is the history of transformation for this is basically specific to the RDD. Okay, this is not for entire job. What is the scope? Scope of a DAG is to the entire job or a stage. Okay, and that is specific to the RDD or data frame in case of lineage graph. In case of execution, used for job planning or optimization, and that is only used for lineage graph, only used for the fault tolerance. This is important in case of DAG and lineage graph. Some persons sometimes getting confused between DAG and lineage graph. Sometimes they understand the similar thing, but there is a bit difference in that. Okay. Then triggered by actions. Okay, and not triggered explicitly. This is internal to the Spark. Okay. Now coming to the visualization part, where we will see all these things. So in Spark UI, if you'll run the local host, you can see DAG visualization under the stage tab. Lineage info usually available in logs, or you can view programmatically by you can print lineage by rdd.to debug string. If you'll do that, you can print the lineage info also. And data visual DAG visualization already under you can see each stage you will see the if you'll run your Spark UI, you will see under this stage. Okay. So this is the concept of lineage graph. So in this topic, we understand what is job, what is stage, what is task. Okay, apart from that, we understand what is driver, what is executor, what is a resource manager. Then we understand what is DAG, what is lineage graph, in which case DAG is required, in which case lineage graph is required, why, what is the scope, and what is the purpose of DAG as lineage graph. Okay, thank you. Thanks for watching.